Okay, Prof. So we are live. It's so good to have Prof here with us on this session today. We have a father, a leader, the person of Professor Abdon Atangana, the president of ASIAM. So good to have you, Prof. You're welcome to this interview session, sir.
Thank you very much, Stephen, and thank you for your, uh, you know, I was not expecting this, but you decided as the webmaster of our ASIAM to start something so that, you should also have our social media live. So thank you very much for your initiation, and I hope that our interview is going to inspire many people.
Thank you so much, Prof. And congratulations on AGM's journal that was published, our first volume. A big congratulations to you, sir, and to the rest of the ACM team. So let me say that now before we talk deeper into all the things we have to say today.
Yes.
So congratulations.
Thank you very much, Stephen, for that. I would like to thank also other people like Professor Makende. I would like to thank all the president of the regional president, the North, Professor Ibrahim, uh, Professor Bakare, Professor Testaman, and Professor Joel, and the president of Central Africa that has been very active. uh, he was also one of the person who also published three or four paper with the team of Central Africa in that volume. Uh, he's from Cameroon. I would like to thank him for his effort. I would like to thank also Professor Gaston Gerigata from United States. I would like also to thank my Chinese, the China Society for Industrial and Applied Mathematics that decided to work with us hand to hand. So we are grateful for this first volume, and I'm pretty sure that the quality of paper that were published there will attract attention of many people. Thank you.
Thank you so much. Prof needs no introduction. We know Prof all over the world. Professor Atangana is well known for his exploits, even in the field of mathematics and applied mathematics. Is is an inspiration to many, to myself, and to a lot of aspiring researchers. So, Prof, I would just like you to tell us about your journey into mathematics. What inspired you? What made you journey into mathematics? We're really curious to know, sir. What brought about this so passion you have for mathematics, sir?
In all the interview, they always ask me this question, and sometimes it look like I repeat myself. I will tell you again that motivated me to do mathematics. I will say that when I was in high school, it was natural that it was better for me to learn mathematics than to learn French and other subjects. So mathematics was, very easy for me. Not like easy. It was a subject that I was able to, to quickly grasp. And when I got my, I went to high school. They were teaching us Pythagoras theorem, Thales, and all those formula. And one day we were discussing with our classmate, and my classmate and myself, at that point we were asking ourselves, wow, all the names, Thales, Pythagoras, and I asked my classmate that, is it, does that means people from our side, from, for example, Cameroon, they never contributed in mathematics? Because here I can't see a name of an African person. And at that point, I told myself that I'm going to do math. Not just to do math, but to make impact. So that one day, a child of Africa should see the name of an African person attached to a mathematical formula. So
Hmm.
when after I finished my high school, I went to the university. From there, I registered in the Department of Math in Cameroon. You know, we have a very serious program in Cameroon that when you come out of there, you will be, very, very strong in mathematics because, first of all, we don't have document. So we rely on chalk. We rely on chalk. And what we do is, we take some exercise from internet, we solve them, and it was like competition, among us. It was not like just to pass. It used to be like competition. My classmate will tell me that he will make sure that he's the first, not the first in our class, not the first in our school, but the first in the whole, the whole region. And I will tell him that, okay, if you want to be the first in the whole region, I have to be the first in the entire province. So it was a very big competition. We passed days and nights solving mathematics on the board. And when we went to the university, all of us, we went to, I think three of us from our group, we went to do mathematics. We did mathematics. And, in Cameroon also when we were doing mathematics, it's a proud because they say that those are the best brain. So it was for me, at the same time, I have the best brain, but also I want to make sure that a formula is attached to an African name. Then when I left the University of Yaoundé, when I came here in South Africa, it was a bit difficult for me because I learned French in Yaoundé. So I came here not only to learn mathematics, but also to learn English. So they have to teach you in English, you have to translate everything in French, understanding in
Mm,
French, and try to do it again in
in
English.
English.
So that is how I finished my honors. I got my master with distinction. I got my PhD. And now what really grabbed me into research, mathematics, uh, when I was doing my PhD, we had some sample, some data. The data are explaining the flow of water underground. And that ground has specific geological formation. It has fractures. And what we do is, we want to know how the water flow under the ground. And we collect data, and we use the existing mathematical model they call Tay's groundwater flow equation. And we compare it, the solution, the exact solution with the data that we obtained from the field. And we saw a deviation. And when there is a deviation between experimental data and mathematical formula, the question is, why we don't have a match? So if we don't have a match, there are two possibilities. Either the data are wrong, or we did not record the data properly, or the mathematical formula is not correct. So we see that the mathematical formula that we have, the model that we have at this point, is correct. The data were recorded several times, it gives us the same thing. So there is a problem somewhere. We think that the formulation of the concept of differentiation that we use to obtain this mathematical model may have some limitation. Not that it's wrong, it may have some limitation. So what is the limitation? Because when you have the derivative, the first derivative gives you the variation between 2 points. But this first derivative is not able to explain to you the history of that variation. So what is happening here is that to obtain the history of the variation, you must convolute it with a specific kernel. And at that point, we knew only one kernel, power law kernel. And it's what we call in mathematics fractional calculus. So that is
Yes, sir.
the time that I start, putting myself effort in mathematics, like to start doing research in mathematics.
Oh wow, Prof, that's so wonderful, sir. I was just thinking, sir, out of all of the areas in mathematics that you could have branched into, mathematics is very broad. and a lot of mathematicians are in several areas of mathematics. So what made you, or what inspired you to go into fractional calculus? What was the inspiration? Because you could have gone into several other areas of mathematics and still do a lot of things and make a lot of impact there, sir. So that's what I'm just curious to know, sir.
Yes. You know, it is a very good question. This question started with, not with me, it started with L'Hopital. L'Hopital, he made several, he provides several formula in differential calculus. When we talk about, for example, the derivative, he provides certain important formulas. And he was curious to know, we are talking about the first derivative. We can understand it. For example, we are speaking about uh, uh, we are speaking about velocity. Then the second derivative, we speak about acceleration. Now, the third derivative, are we saying that is the rate of change of the acceleration? Now, the fourth derivative. So we are first, second, third, and n derivative. And L'Hopital is asking Leibniz what happened if that n is, for example, 0.5. At that point, even Leibniz was unable to answer the question. So people like Liouville started, he took exponential function, he differentiated exponential function. If you have exponential lambda t, the first derivative we have give you lambda exponential or lambda t. Second derivative is going to give you lambda squared. So you carry on, you ask yourself, if this n is a fraction, what will happen? So many important, work has been done. The work of Riemann, the work of Liouville, the work of Cauchy, and they came out with a formula. At that point, the Cauchy formula that if you integrate a function several times, you will see that it is, maybe if you integrate it n time, you will see that it is actually exactly the convolution of x to the power n minus 1 and the function when the function is continuous. And that gave birth to what they call a fractional integral, because if n is replaced by a fractional number, we have a fractional integral. From the fractional integral, we build what they call a fractional derivative. So why fractional derivative? Let me tell you something, Kelvin. Our world is not about continuity. Many people, they don't want to know how the something continue. Many people want to know the change. And when we speak about change, we speak then about classical derivative. And classical derivative is very important for classical mechanics. I will give you a simple example. With the classical derivative, we are able to express, a continuous velocity. If you put a car, for example, you take cruise control, you put a car 120, that car will go 120 until it reach where you want it to go. But it will not remember the history of the path. Then now, there are many real world problems that you see that they have memory. When I talk about memory, they remember what happened in the past. And for example, if you are dealing with the process of the spread of disease, when the disease is spreading, the disease is not spreading smoothly. Like, okay, one
Yes, sir.
person will be infected after 2 people, after 3 people. No, there are several important factors that play so that the spray can be, can have some type of memory. And that is where the concept of fractional calculus came to play. And with that concept of fractional calculus, we are able to model processes. For example, if you are dealing with the movement of water in a specific geological formation, that has you know, the structure of the soil is not the same from here to there. So the concept of classical calculus is not able to reproduce that type of behavior. So there are several behavior like that in nature where you see a trend of power law. You see that the process start and decline very slowly, and then when it reach a specific time, it start going very slow. I will give you an example of the decomposition of a human being that has the flesh, that has, for example, the bones. At the beginning, you see that the, the decay is very fast. That decay is very fast. At the end, you will see that the decay is very slow. If you are recording the mass of that dead body as a function of time, you realize that at the beginning the mass will reduce very significantly. At the end, it's going to reduce very slowly. It reduces significantly because of the structure of the flesh and but it becomes very slow because of the bones. So those are the process that we see in nature that cannot be modeled using the classical differential operator. That is the reason why at some point I asked myself, this deviation that we saw between our experimental data and the mathematical model that used the classical derivative, now we were able now to use fractional calculus, capital derivative, and we saw that when alpha was equal to 0.98, we got a perfect agreement between the data and that alpha was expressing us the presence of a fracture in that geological formation. That is what attracted my attention in the field of fractional calculus, because it can be applied in many fields. So what I want to say is that uh, fractional calculus has impact as classical calculus, because you start with a derivative. You can study a function, the variation of the function with the classical derivative. If the function increase, if the function decrease, but with the fractional calculus, you cannot only study it like that. You have to study also it about with the fractional order. So from there, you are able to build, you know, differential equation. The differential equation now are being used to model many problems in all field of science. So when you are learning fractional calculus, know that you're going to have impact in all field of science. That's why I embark in the field of fractional calculus.
Oh, well done, sir. And the impact is seen worldwide. And thank you so much, sir, for your passion. And this will lead me to my next question, sir. Why are you so passionate about Africa? We see a lot of people who do not really care. Um, they don't care so much about Africa and the growth and the development of Africa. But why do you care so much about Africa? What is this passion for Africa about? And why do you so care about Africa? With the opportunities that you've had, you could have decided to maybe go to Europe and establish somewhere. And but why do you care so much about Africa, sir?
Uh, Very good question, Stephen. As an African child, you will see that when I speak about this topic, I become very serious. I become emotional, and you can even see that my face changed because as an African child, when you are born crying. You are born crying because if you take a plane now to go to maybe Malaysia or Europe, you may be, as a black person and as an African person, you may be the only person that will be suspected in the plane. When you reach anywhere, and it happened that you are from Africa, most of the time they suspect you. Even our the African people that migrated from here and went to United States, they will tell you the same thing when they are on the street. The bad person is only the person coming from Africa. And that impact us in several ways. In academic, for example, you will notice that journals, Africa don't have journals. We don't have our publisher. We don't have our society that determine what is the impact factor. We don't have strong journal. And textbook and many several things. We don't have hand to say that this is Africa. And when I was doing my PhD, I read a portion of a scripture that says, I went to Africa, I went to the north, east, west. I did not find anybody that back in that country. That it's a country with people with high good moral. And it is a country where you don't see people stealing. They work extremely very hard. And that person says that if we don't break their very backbone, that is their system of education, and tell them that whatever they do is not good. For example, their languages, they are not good, that it is only English that is good. We must make sure that they become a dominated nation. And that is what we are today.
Yes, sir.
That is what we are, a dominated nation. The division, Europe, Cameroon, and all these things. So you ask ourselves, why is it that we as African child, we as African, we don't make impact globally? Most of the time, we will notice that when there is a good person, a talent from our continent, 3 days later, he will go overseas. And Africa stay with that talent. And you know, when God put you somewhere, God put you somewhere for a purpose. God made me to be African. And there is a time, to sacrifice yourself so that the next generation should benefit. There is a time to say that it is not about me. It is about leaving a legacy. That one day an African child will be in the plane. And they will tell him that you can also sit here proudly because the specific theorem that was used to make this plane came from Africa. You can sit here because a specific development that made this plane stable in the air came from Africa. Because we see the difference between somebody who comes from England, for example. He is proud, not because of what he has done, but because of what his people did before. And that is why African people have to recognize that for us to make impact, for our next generation to be considered, we need to work hard being in our continent. And we don't work hard to get medal for ourselves. We work hard to open doors for the next generation. That's why I am passionate, begging God, asking God to give me strength, so that before I leave the earth, I will create some doors for the next generation. That's what I can tell you.
Wow. Wow, thank you so much, sir. That is so inspiring, sir, because there are very, very few people that have the same passion as you do, sir. And for the young ones like myself and so many other Africans out there, this is what we look at, and then we know that there's actually hope for Africa. And this will even lead me to the next question I would like to ask, because now we have a platform called ASIAM, which stands for the African Society for Industrial and Applied Mathematics. I would like to ask her, how did it come to be? What was your mind before it came about, and how did ACM come to be? Looking at a platform that can bridge this gap. So that's my question, sir. Looking at ACM.
Yeah. Thank you very much, Kelvin, for this question. A few years ago, I was appointed as a chair of research and innovation from African mathematical African mathematical AMS. Yes. So
Union.
yeah, union. So uh, for in my portfolio, I have to organize conferences in many places. Of course, there's no budget for it. I have to create budget for myself. I have to do something. Then we started with a conference in Rwanda. At the beginning, all the team was there. At some point, some people were discouraged because they did not see any money, and they said that the conference cannot take place. And I contacted Professor Makinde. I told him that, Prof. Makinde, I would like you to come and be plenary speaker in this conference. He told me, yes, I'm coming. So we went to Rwanda. We organized a conference. I went there with 14 students from here, from South Africa. Professor Makinde also came with a group of students. Then during our meeting, we received the president of the International Council for Applied and Industrial Mathematics, Professor Will, who challenged us, telling us that he's not seen any movement in Africa about applied and industrial mathematics. So Professor Makinde and myself, we looked at each other and we told him that it is true, because his point was, we don't go to their conferences. And we told him that, Prof. Will, we would like to come to your conference, but there are few important things that have to be fixed. We cannot only come to conference and listen or be taught. We also want to come to a conference and teach. We should not only be like kids. They pay our ticket, we go to sit. We only receive what people have done, but we never present our work. And we told him that before we start coming to your conferences, we will also create a society in Africa. And Professor Makinde and myself came out with the name African Society for Industrial and Applied Mathematics, ASIAM. And we told Professor Will, next year this time, ASIAM will be inaugurated in South Africa. He told us that he is not sure, because to start a society is not easy. So when we came to South Africa, I noticed the fire in Professor Makinde. And I told myself, this is the elder person with whom I can work, because I can see that he has passion to do something for the continent. And I would like to see Professor Makinde everywhere. I want to see him I want to have Professor Makinde in the north. I want to see Professor Makinde south. I want to see what I'm saying, that I want to see him everywhere. I want our elder, African elder, all of them to be like Professor Makinde, because most of them, they think that when they go to Europe, they take pictures that they were in a conference. That give them glory. No, glory have to be given to you when you create your own thing and give value to it. That is what Professor Makinde is doing. That is why I like him. Besides Professor Makinde, we've got Professor Gaston in the United States, who also said, yes, we have to do this. Then we started this conference as a joke. I called Mr. Makinde, we are going to have a conference at the end of the year. We will not have any fun, anything. So he said, okay, we are going to do it. We started a campaign. We want to organize a conference. So people start coming. And last year, during my birthday, God made it to become true. We organized ASIAM, and many people came from Europe, people came from Russia, from Czech, from Italy, from America. We call all the president of many mathematical society. People come from China, very big delegation came from China, and ASIAM was inaugurated. That is how ASIAM came. We invited the president of the director of Springer. He was there. That's how ASIAM was created. And so far we have worked very hard. ASIAM is now in more than 40 countries in Africa. We will continue working hard so that it should be in all the countries in Africa. So that's what we did to have ASIAM up to now. Thank you.
Wow. I'm so inspired by the story of ASIAM. It's one that it's a story that is almost a fairy tale. It's one that inspires hope and dreams coming to pass. And as the president of ASIAM, sir, where do you see ASIAM going to in the nearest future? What do you see ASIAM becoming? Even for the African hope, where do you see ASEAN in the next few years to come? What's your desire for ASEAN and what's your vision for ASEAN, sir?
Let me tell you something, Kelvin. In the Bible, there is a very important story that I like. There was no rain in the area for many years. And the prophet of God told his disciple, we will pray God to make rain come in our soil. Everybody was saying, it is difficult, it is difficult because of this, because of that. You don't have money, you don't have this, you don't have power, you don't have... He said, we will pray God for the rain to flow, to come down, water to come down in our... And he put his face down and he told his disciple, go and check. Are you seeing a small, I don't know how they call it in English, nuage?
A cloud.
Cloud. Yes. Do you see a small cloud somewhere? The disciple said, no, I don't see. He continued praying. And he asked again, do you see a cloud somewhere? He said, yes. I'm seeing it as a small hand of a human being. It is very small. And he told him, go back in the village. Tell the whole village to prepare. Because rain is going to flow. We are going to have rain and water in abundance in our soil. Stephen, listen to me very carefully. ASIAM is now a small cloud hanging on top of Africa. Prof. Makinde and myself and the other regional president, our faces are on the floor, telling God that we want to see African people using mathematics to develop their continent. We want to see African people introducing new technology because of the mathematics that are developed from Africa. Praying God, telling God that we want to see in our soil our younger one coming back home and learning serious mathematics and making impact. Telling God that we want to see in the near future African Society for Industrial and Applied Mathematics having many journals where African people can publish their paper without any discrimination. Praying God that every year we should have a very big conference that will gather all African people, where they will go and sit and present their innovation, show the world what they have done, without asking for funding from the West. Our heads are on the floor. Praying God, telling him, this is what we want to see. And we are working hard, myself and you, Stephen, on your side, as you have started this, what we are doing today. That's what I want to see. I want to see a young African person using mathematics to solve the problem of water pollution in his country. I would like to see a young African person being employed by the government to solve a political problem that he will model using mathematics, because that is what the West is doing. That's why they are so advanced, because they understood that mathematics is the key, is the key to open door for the progress, to open door for new technology. That's what China is doing. I want to see ASIAM being a very serious, well-established society that will make impact to Africa. So that when there is a COVID, that when there is outbreak of a specific disease, instead of our people looking for experts from the West, they will come to our society to say what is the model that we can establish to predict what is going to happen and what are the advice. That is where I want to see ASIAM in the next 20 years. Thank you.
Wow. Thank you so much, Prof. That's a very massive vision and one that we can keep praying to God that God will help us to fulfill even in our time. And my just two more questions before I release Prof for today. I would like to ask Prof, what's your advice for young researchers coming up? For a lot of researchers, we have you as a father that we look up to. What's your advice? Because as you said, a lot of offers, people want to leave Africa and go to Europe. They believe that there are opportunities over there and more exposure. But what's your advice for young researchers who are coming up who feel like there's nothing in Africa for them, but until they leave Africa before they can become something of repute? What's your advice for young researchers just coming up, sir?
No, my advice is very simple. The way you fix your bed, that is the way you are going to sleep also. Paradise is not in the West. Paradise is here in Africa, where God placed you. So I would like to tell young researchers from Africa that our country, Africa, that was divided. Today, I cannot come to Nigeria without visa, whereas it's my country. I cannot go to Rwanda. I cannot go to Ghana. Let us work hard in our soil with what we have to change the future of our next generation. Because we go to the West in search of greener pasture. This is because their elder, they work hard and they open door for the next generation. So we, as the present generation, should do the same thing for our next generation. Mathematics is the same everywhere. Mathematics is the same in Africa, in Europe, in China. Mathematics is the same everywhere. So let us stay in our continent, work hard in our continent, develop new technology in our continent, so that one day somebody from UK will say, let me go and register in an African university to study this theorem that was developed by an African. Let us work hard. It is our time. Nobody will do it for us. The hand will not come from heaven. But what is important for me is that we should work hand to hand from the north to the south, united, so that we make impact. Because, you know, in the Bible there is important scripture that always caught my that always make me to think properly. You know, human being decided to gather somewhere. When they gather in that place, they decided to build a tower that will reach heaven. And the Bible is telling us that they start building this place until God himself said, can you see what they are doing? And he said, can you see what they are doing? If we don't scatter them, they will make sure they will reach where they want to reach. And you know, they were doing that thing against the will of God. But imagine if young Africans do the same thing to build the Tower of Babel of Africa under the watch of God, within the will of God. Imagine that beside our effort, God had also his own anointing, his own grace upon us. We will change the world. So let us work together. We should not think that when you write a paper, from another country, let us work together. Thank you.
Thank you so much, Prof. Let us work together. That's the message for everyone for today. Let's work together. Finally, Prof, I don't know if you have a parting message. Just as you said, let us work together. But you might have an encouragement, a word for ASIAM family all over the 40 African countries. You might have a word for the general public. We like to have you, sir. Just give us a word, sir.
Yes. Let me just conclude. Because most of the time, people are asking how important is industrial and applied mathematics. Industrial and applied mathematics can play a transformative role in addressing the real world in African community by providing data gripping, efficient, scalable solution across multiple sectors. Let me give you a list of some problems that we can solve using mathematics. We have, for example, water resource management, where we can model groundwater, leak detection and water distribution, rainwater harvesting. We can speak about agriculture and food security. We can speak about public health. For example, epidemiological modeling. How you can model the spread of a specific disease like malaria, COVID, using mathematical to help in resource planning and intervention. You people do it in Nigeria already. We are speaking about sanitation planning. Okay, we can speak about access, energy access astronaut. We can speak about climate change and disaster management. We can speak about education and research and transport and urban planning, mining and natural resource, So all those things can be solved
So
using
all those
mathematical
things can be
formula.
solved using mathematical formula.
So to end,
So to
I would
end,
like to
I would
thank
like
all the
to
president of
thank all the
the
president of
national president for the work they are
national
doing
president
already,
for the work they are doing already,
the regional president,
the regional president,
the secretaries,
the secretary,
our
our
IT,
IT,
that you are the chief,
that you are
you are in
the chief,
charge.
you are in charge.
So I would like us to
So I
continue
would like
working
us
very
to
hard
continue
so
working very
that
hard
our
so that
society
our society
should also be
should
impactful
also be impactful
as the other
as
society
the other
from
society
the West.
from the West.
I would like to thank them,
I would like to
everybody,
thank them, everybody,
the president of all
the
the
president of
commissions,
all the commissions,
and I would like
and
also to
I
thank,
would like also to thank
the editorial
the
board of
editorial board
the
of
African
the
Journal
African
of Statistical and
Journal
Applied Mathematics that has brought the
of
first volume.
Mathematics.
That is
That
for
is
us. It is a first
for us,
victory.
it's the first victory.
I'm calling
And
all
I'm
African
calling all
people
African people
to submit their
to
paper in
submit
that
their
journal so
paper
that
in
in the
that
next three,
class so
four
that
years
in the next
we
three,
should
four
have
years
also impact
we should
factor.
have also impact factor.
I would like to thank
I would like to thank
you, Stephen,
you,
for what
Stephen,
you are doing,
for what you are doing,
using your own resource
using your own
trying
resource
to do something
to
for
try
the
to do
society.
something for the
Thank
society.
you, and God
Thank you
bless
and God bless
ASIAM. Thank you.
Thank you.
Thank you so much, Prof. And God bless you too, sir, for showing us the way and leading us even in this part. Thank you for your time, Prof. We are so glad to have you today. We hope to even have more of you in our future sessions where we discuss much more about Africa and the development that is taking place because of mathematics. Thank you so much, Prof. We've come to the end of this interview session. Do have a very wonderful time, sir.
Thank you.